application problems of quadratics. First, I want to start off with some tips. The first thing you should always do is take a look and ask yourself, what form is the function given in? Is it vertex form? Is it intercept form? Or is it standard form? Once you determine what form it is, then you can ask yourself, how can that form be helpful? So what information do you get just by looking at it? Vertex form gives you the vertex, intercept form gives you the x-intercepts, and standard form would give you the y-intercept. So what information do we know given the function? Then look for key terms like minimum and maximum. Minimum and maximum mean you need to know what the vertex is. And keep in mind that units matter. Ask yourself, does it make sense? You should always write your final answer with your units of measure as well. We can use Desmos to help us graph the function, or we can just draw some rough sketch, which is probably what I'm going to do. For number 1, it says an object is launched from a platform. The equation for the object's height, s, so that's important, at time t after launch is this equation right here, where s is measured in meters. So before I even, try to answer these next questions, I'm analyzing that first part. This equation, what form is it written in? Well, it looks like y equals ax squared plus bx plus c, which is standard form. The details that I know just by looking at standard form, there's a couple of things. First, I know that the c value is the y-intercept, so I have a y-intercept at 58.8. Second, I do notice that I have a negative a value, so my parabola is going to open down, and I'm going to have a maximum. And then the third thing is I can solve for some of this information. So if I'm drawing a rough sketch, my y-intercept is 58.8. I know it's a parabola that is opening down, so that means it's going to pass through that point, reach some sort of maximum, and come back down and hit the x-axis. So there's my rough sketch of the situation. So if we're talking about an object being launched, here's the path, and then it's going to land here on the ground. If I want to fill out more information, I can easily solve for it. Standard form, I know I could get the axis of symmetry using x equals negative b over 2a. So I'm going to do that solving down here. X equals negative, b was 19.6 divided by 2 times negative 4.9. Now, if you're plugging this into your calculator all at once, you can. You would just have to make sure that you put your entire denominator inside of parentheses, because you need to group the numbers together. If you don't put them in parentheses, you're going to get the wrong answer. Hit enter, I see that x equals 2. So, I know the x value is 2 for my axis of symmetry or my vertex, because these numbers always match. To find the height, then, I'm going to need the y value. Well, to find the y value, I should know that all I have to do is plug the x value back into the original equation that I have up here. So I'll do that in this space. That gives me negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. Let me switch that up for you. So plugging it in, negative 4.9 times 2 being squared plus 19.6 times 2 plus 58.8. Hit enter. I get 78.4. So y equals 78.4. Right there. So I got the x, I got the y, which means I have my vertex. 78.4. Now that I have the rough sketch and I understand what's happening, I can take a look here. At what time does the object reach its maximum height? So the question is, At what time does it reach its maximum? Keyword. Maximum means vertex. Do keep in mind, it tells you in the story problem that height is the S and time is the T. S is in the Y position. T is in the X position of my standard form. So that means that the X is T, the Y is S. If I want to know what time does it reach its max, that's 2 seconds. Notice how I put my unit of measure. There is another question here. What is this height? So now I want to know, what is the maximum height? Well, that would be the 78.4. And it says up here that the height is measured in meters. Part B. What is the height of the platform from which the object was launched? So it's not asking about the max anymore. That's dealing with the starting point. When it started, what height did it start at? Well, that's our y-intercept, which was 58.8. Once again, you do need to put your units of measure. That would be 58.8 meters. Let's take a look at another story problem. For this next one, it says the path of a football can be modeled by this equation here, where x is the horizontal distance in yards and h of x is the height in yards. A field goal kicker is practicing his distance. Before I even worry about this, I'm going to analyze it. So I have an equation. At first, some people might think it looks like vertex form because they only see one parentheses, but that parentheses is not being squared. It actually would be intercept form, which looks like y equals a times x minus p times x minus q. So looking at this equation, I see that a is negative 0.02, p is going to be 0, because x is like x minus 0, q is 60. Because it's x minus q, you change the sign from what you see, or you could set it equal to 0 and solve. You'll get 60. So details, what do I know? P and Q are my x-intercepts. So if I'm drawing a rough sketch, I know my parabola is going to open down because I have a negative a value, so I'll have a maximum. So there's a max right there. My intercepts are 0 and 60. So I already know 2 of my 3 points. My vertex, do keep in mind with intercept form, the axis of symmetry is exactly halfway in between. So halfway in between 0 and 60 is 30. So for my vertex, I know the x value. I can easily solve for the y value by taking that number, plugging it into the original equation. So that's y equals negative 0.02 times 30 minus 60. So I'll show you how I plug that in my calculator. Negative 0.02 times 30 minus 60. Hit enter. I get 18. Now that I have a rough sketch, now that I can visualize, okay, here's my little kicker here. He kicks the football. It goes up, reaches a max, comes back down. Then I can answer these questions. A, how far did he kick the ball? So when he kicked it, it hit a max and landed at 60. 60, look back up, 60 yards. Part B, what is the maximum height? So maximum tells you vertex. We need to look at the vertex. But you need to answer the question, what is the maximum height? X is the horizontal distance, so 30, my x value is my horizontal distance. H of x, which is in the y position of intercept form, is the height in yards. So my answer here, if I want maximum height, that's going to be the 18, and I would put my units of measure yards. So we answered the 2 questions. We're good to move on. The function s of t equals this right here, models the jump of a red kangaroo, where x and y are both measured in feet. Before I even answer the rest, let me analyze it real quick. This looks like vertex form. So vertex form has that general equation right here. I recognize it was vertex form because I had a binomial being squared. That's what gave it away for me. So key details first, my a value does tell me something. It's negative, so I know my parabola is opening down and I'll have a max. The other thing I know, just by looking at vertex form, you can tell the vertex. It's h comma k. Don't forget though, change the sign for h, keep the sign for k. So if I'm thinking about my rough sketch, I know that the kangaroo jumps and lands. At some point, that kangaroo is going to reach a maximum. It happens to be at 14.6 for me. So it says, what is the maximum height the kangaroo reaches? Well, the maximum height, I'm going to look at the vertex because keyword maximum means vertex, okay? And height would be, if you're looking at it, this would be the horizontal distance, and this would be the height right here. So I want the y value. And it did say measured in feet, so I'm going to say 6 feet. And then part B, at what horizontal distance in its jump does the kangaroo reach this height? So that would be the x value. So I would say 14 feet. This next one says, if you are 36 feet away from the kangaroo when he jumps, will you be safe? Well, let's see. A way that you can determine that is horizontal distance would be x. You could plug 36 into the equation. So 36 minus 14 squared plus 6. And plug this in. Negative 0.03 times 36 minus 14 being squared plus 6. Hit enter. I got a negative 8.52. So what does that mean? So that means in the graph at 36, it would be like a negative 8.52. Negative height doesn't make sense. So that means I'm probably standing further away. If that looks confusing, I'm going to say yes, we are going to be safe because the kangaroo is probably landing here. The kangaroo landed there, and that's my little kangaroo right there with the big feet. How about that? So it's going to land probably right around in front of me, but I'm safe for now when he's jumping. When I plugged it into Desmos, I'll show you. So you can go to desmos.com and plug in this equation right here to see the intercepts. I have a rough sketch here for you guys. When I plugged it in, I saw that the x-intercepts were negative 0.142 and then 28.142. So when the kangaroo jumped, he landed at 28.14. If you're standing at 30 feet, he will land right in front of you. He didn't jump on you, which is great. So you're safe for now, but what he does after he jumps, I'm not sure.